Okay, sorry. Good afternoon, everyone. Good afternoon. Okay, just check that graph, page number 4, the first graph. Atomic number is what? Atomic radius. So down the group, atomic radius is the down the group. I or D? Why? Number of shells increases. So therefore, naka. Atomic number of shells increases, atomic radius increases. Okay? Ata. Across the period, what happens? I or D? D. Why? Electron enters into the, sorry, atomic number increases, electron enter into the same shell, so effective nuclear charge increases, so force of attraction between the nucleus and the outermost electron is very strong. As a result, size decreases. Clear? Joseph, okay? Fizika, okay? Benjamin, okay? Two sodo. You are not able to ionization enthalpy. Are you there? Okay. Half you went? Oh, good. Master Kalapana. I will try my best. Okay. Lithium to beryllium, can you see the atomic radius is decreasing across the period? Beryllium to boron, carbon to nitrogen, nitrogen to oxygen. किती लोगों? Nitrogen is a half stable configuration. That is ionization enthalpy. This is atomic radius. मार पट्टाला दोन्ही confuse करना का? हाँ. I'm saying why the atomic radius actually from nitrogen to oxygen should decrease, but in the graph it is increasing. Why? When you same thing, not the same thing. You are confusing ionization enthalpy with atomic radius. Okay. Ionization enthalpy, this reason is applicable, but for ionization enthalpy. Now it is actually from nitrogen to oxygen, one electron is added in oxygen. As a result of it, there will be inter-electronic repulsion. And this outweighs whom? Effective nuclear charge. So size increases. As per us, oxygen to fluorine, size is decrease. Again, oxygen to fluorine, one electron is added. There will be inter-electronic repulsion, but here, effective nuclear charge outweighs whom? Inter-electronic repulsion. Clear, Ata? Ata, come back on the page number 5. I. Ionization enthalpy. Ionization enthalpy, factors affecting ionization enthalpy is very important. Understand it thoroughly. Understand ना बाहेर करना का. Understand आहे ना तर study करना का. I'm telling you directly. Understand है ना study करना का. Understand असा ना thoroughly study करू पाहिजे. Any question comes, you should know the answer. Okay, so graph understand story. आम्ही first graph. दिसते पट्टा atomic number and ionization enthalpy. Yes or no? So, well, very simple thing. Lithium to neon across the period, what happens to the size? Size decrease जाता सारखे. So ionization enthalpy should be across the period. Ionization enthalpy should increase सारखे नाही, because size की जाता decrease जाता. Size decrease of the electrons are strongly held, tightly held by the nucleus. So if the electrons are tightly held by the nucleus, so more energy required to remove the electrons across the period. Yes or no? So ionization enthalpy across the period should what? Increase. But now check the graph. Lithium to beryllium, is it increasing? Yes. But beryllium to boron, it is a what? Decreasing. Why? Because beryllium, what is the configuration of beryllium? 1s2, 2s2. Fully filled stable configuration. Don't say noble gas, huh? Fully filled stable configuration. What is the electronic configuration of boron? 1s2, 2s2, 2p1. So it is easy to, boron will say remove that electron from p, yes or no? Because he will attain what? Fully filled stable configuration. Therefore, ionization enthalpy, beryllium to boron decreases. Again, boron to carbon, carbon to nitrogen, nitrogen to oxygen decreases. Tell me the reason. Because nitrogen has a half-filled stable configuration. And what is the electronic configuration of oxygen? 2p4. 1s2, 2s2, 2p4. So oxygen will allow to remove that electron, one electron. Why it will allow? Because it will attain what? Half-filled stable configuration. In the exam, while explaining this, write the electronic configuration for every element and explain for both nitrogen as well as what? Oxygen. So that teacher marks cut करपा chances ना. Okay, and if teacher is saying why you written both, because both the reasons are applicable. Nitrogen ionization enthalpy चढ किती असतली as oxygen, because it has half filled. Oxygen is less kitastally because it will try to become half change. That's why I've written both. Okay, I'm not saying anything wrong here. Okay, okay, very good, very good, very good. So I will start with the next part, today's part, to understand from you. That is electron gain enthalpy. Electron gain enthalpy. Now there will be a mess. Mess म्हळ्यार सगळे कन्सेप्ट आता ऑलरेडी स्टार्ट केलें एटॉमिक रेडियस आयनेशन एंथैल्पी आता आयनेशन एंथैल्पी इलेक्ट्रॉन गेन एंथैल्पी electronegativity you will feel like same but it is different. That's why I have told you the definitions. So electron ionization enthalpy म्हळ्यार energy required to remove the electron from the outermost shell. Okay, so now check the definition of electron gain. Meaning कितें gain म्हटल्यार जी अल्लाह के नाम पे इलेक्ट्रॉन दे दे, अल्लाह के नाम पे इलेक्ट्रॉन दे दे. इलेक्ट्रॉन गेन जितने बेगिन तुम यू विल डू द मोर इलेक्ट्रॉन यू विल गेट. क्या नहीं कमाई होगी इलेक्ट्रॉन की. सेम थिंग हियर it is defined as what is the meaning of enthalpy? Energy. Enthalpy change when electron is added to an isolated gaseous atom. See the thing here, it is what enthalpy change, energy change. What is ionization enthalpy? Amount of energy required. This is what amount of enthalpy change when electron is what added to whom? Isolated gaseous atom. Take example of okay? Electron gain enthalpy may be exothermic or endothermic. I hope you know what is exothermic, endothermic. हे झालं गेले पेनाचे हा जाय त्यानं कलरिंग पेन हाडून नाते वाटता एकमेका पेन हांगा धरून हे कलरफुल करपाचितला हे जो चान कितें पेन आयजो हाडली तूं म्हाका आयजो हाडला काय पयर हाडला तेंगेर हाडले आयजो आतां हाडला क्लासीन एकमेका पेन वाटता. I will make you sit here, huh? Somewhere here. Thank you. एक दिस start केला नाही focus. Okay, electron gain enthalpy may be what? Exothermic or endothermic, but for many reactions, energy is released when an electron is added to an atom. Energy is what? Released. Which reaction? Exothermic or endothermic? Exothermic. So delta H will be negative. Delta H म्हटल्यार enthalpy, the symbol for enthalpy is H. So delta H like change in enthalpy. And thermodynamics, this is thermodynamics. Enthalpy is thermodynamic term. So thermodynamics details सांगता enthalpy म्हणे. आता इतल्याच याद धर enthalpy म्हळ्यार कितें energy and it is given by a symbol called what? H. And delta H म्हळ्यार कितें change in enthalpy. And change in enthalpy is what? Negative. म्हटल्यार which reaction? Exothermic. Clear आसा? Okay, good. Next point. Group 17 elements have highly negative electron gain enthalpy. Group 17 म्हळ्यार कोण आमगेले? Group 17. अरे म्हाका बरी याद जालें. नेत्रावजी म्हाका सांग जनरल इलेक्ट्रॉनिक कॉन्फिगरेशन ऑफ पी ब्लॉक. NS1 to 2 and noble gas हाडले आणि NS1 to 2 आसा half correct. Noble gas configuration of p block, electronic configuration of p block किती उलयत कोणा खबर आहे? Noble gas NH2 NP 1 to 2 1 to 6 sorry 1 to 6. Okay, S block noble gas S block group 1 noble gas NS1 and group 2 noble gas NH2. Full S block noble gas NS 1 to 2. D block noble gas N-1 D NS 1 to 2 N minus D is 1 to 10. F block N minus 2 F N minus 1 D 1 to 14 correct. N minus 1 D 0 to 1 and NS 2. Okay. So group 17 elements have highly negative electron gain enthalpy. Group 17 कोण आमगेले पया? Fluorine, chlorine, bromine and कोण? Iodine. I will do only for fluorine and chlorine. Okay. What is the electronic configuration of fluorine? 1s2, 2s2, 2p5. Fluorine किती? 1s2, 2s2, 2p6, 3H2 and 3p5. Okay, electronic configuration. Now go for the reason because they have strong tendency to accept an electron to acquire what? Stable noble gas configuration. For electron gain enthalpy, if it is more negative, म्हटल्यार त्याची टेंडन्सी कितें इलेक्ट्रॉन घेवपाची हाय. अंडरस्टँड जालें? परत सांगता. Electron gain enthalpy, if it is more negative, then what is the tendency to gain electron is what? High. Why these have more tendency to take electron? Why? Yes, only one electron is required. But why they have more tendency? तशी कार्बनाक आमगेल्या दोन इलेक्ट्रॉन्स जाय. Yes or no? But only group 17 म्हणून mention केला न्ही. Why? What they are saying that group 17 have high electron gain enthalpy. High electron gain enthalpy मतलब it is more what? Negative. So why they will have more tendency to gain electrons? Because they will attain what? Stable noble gas configuration. Ekon metal, neon, ekon metal, argon, bromina kon metal, krypton. Helium, neon, argon, krypton. Are you getting the things here? So they will gain the electrons. Are you getting the thing? At next part two. Understand that, Tani? Clear, Asa? Okay. Don't mix the concepts now. I'm keeping it very clear. I'm keeping it very clear. JG tendency high asa to take the electron is a electron gain enthalpy value किती असतलो? More negative असतलो. More negative means more tendency to gain the electron. Group 17 has more tendency to gain the electrons. Therefore, it has a what? High electron gain enthalpy. Why they have more tendency to gain the electrons? Because they will attain what? Stable noble gas configuration. Okay, now just read the point again. Group 70 elements have high electron gain negative. High negative, huh? High negative. High electron gain enthalpy. High negative electron gain enthalpy. See, highlight that negative word. High negative electron gain enthalpy because they have strong tendency to accept an electron to acquire stable noble gas configuration. Understand Zala? Understand Zala? Atmastam, don't read the next point. कोणाची हाय पॉझिटिव्ह असतली ग्रुप टेल मी. मतलब आता हाय पॉझिटिव्ह म्हणजे दे डोंट हॅव दॅट टेंडन्सी टू टेक इलेक्ट्रॉन सारखे. हाय पॉझिटिव्ह म्हणजे मिनिंग कितें? दे विल नॉट हॅव दॅट मच टेंडन्सी टू गेन इलेक्ट्रॉन. खंयचो ग्रुप असतलो? ट्राय करा पळया. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. Which group? It will be group 18. Group 18 will take an electron. They require electron. I will just write here group 18. पळया. Group 18 कोण आमगेलो? Helium, neon, argon, krypton, xenon. Will they take an electron? Will they have a tendency to take an electron? No. Why? Because they have a stable configuration, fully filled stable configuration. त्यांका noble gas म्हणटा. They are noble gas. त्यांका answer करूचे because they are getting stable noble. Okay? Because they have what? Stable, fully filled configuration. Now read the second point. Group 18 elements have highly positive electron gain enthalpy. Accept karta because when they gain electron, it enters the next principal quantum number. Sarke, yes or no? So leading to unstable electronic configuration. In short, I can write they already have what? Fully filled stable configuration. Anek electron it will go into the next shell. The unstable the flow. The meaning is same because they have fully filled stable configuration. Clear electron gain enthalpy? Understood? Okay, good. And बारीक सा point which I already explained, but for example, if an electron has more tendency to accept electron, large amount of energy will be what? Released. I'm just repeating again. If an atom has more tendency to accept electron, large amount of energy will be what? Released. Which reaction will take place? Exothermic. And electron gain enthalpy will be what? Highly negative. More tendency to accept electron means more negative will be electron gain enthalpy. If an atom has a less tendency to accept an electron, small amount of energy will be released, leading to small negative value of electron gain enthalpy. Exam question ko se done to. They will give you two values. delta H is equal to minus 72 kilocalories something, and delta H is equal to minus 138. Like this, they will give, and they will mark this as A and B, and they will ask you which which of these two atoms have higher tendency to gain an electron. Tell me, which of these two atoms will have high tendency to gain electron? A or B? More negative. It will be, more tendency, more negative, like more tendency to accept electron. Are you getting the things here? Like this also the question. Clear? And more negative, more tendency reaction किती असतले? More exothermic. Okay. So this is about the electron gain enthalpy. आता factors affecting electron gain enthalpy. हे मातशे boring जातले factors affecting. It's interesting ना आहे. I think Einstein enthalpy was good, ne? When the reaction is endothermic, when I should say when we compare, for example, A element असा, B element असा आणि C element असा. म्हाका हा क्वेश्चन असो विचारपाक शकतो का which is more exothermic or which is more endothermic? I can say like that. आता जर एनर्जी लेस रिलीज जाता, एक्चुअली इलेक्ट्रॉन गेन जर तो इलेक्ट्रॉन गेन करता न्ही जाल्यार तो एनर्जी रिलीज करतलो, बट तो इलेक्ट्रॉन जर रिलीज करता त्याची एनर्जी घेतलो न्ही that will be endothermic. But electron concept is what electron gain enthalpy. So there is no concept, there is no term where endothermic will come. Understanding? इलेक्ट्रॉन जर घेता म्हळ्यार तो एनर्जी रिलीज करता, जर ताका एनर्जी घेतल्यार तो इलेक्ट्रॉन रिलीज करतलो. So the concept is electron gain enthalpy. So I can just tell you that it can be either more negative or less negative. So the exothermic reaction will take place for sure. They have not mentioned any word for endothermic there. ठीक है, क्वेश्चन पलटूंगा किती चलतो तर विचार म्हाका सर एंडोथर्मिक रिएक्शन केन्ना जाता? एंडोथर्मिक रिएक्शन कित्याक जावपाना हांगा? बिकॉज द कन्सेप्ट इज इलेक्ट्रॉन गेन एंथैल्पी, आनी इलेक्ट्रॉन जेन्ना कोण घेता तो खंयची रिएक्शन करता, एनर्जी किती करता? रिलीज. सो एवरी टाइम ते एक्झोथर्मिकूच जातलें. बट म्हाजे कडेन जर दोन एटम आसता ए आनी बी, ए हॅज अ हाय टेंडन्सी, बी हॅज अ लो टेंडन्सी, जर हांगा मोर एक्झोथर्मिक आसतलें हांगा कितें आसतलें? लेस एक्झोथर्मिक. एक्झोथर्मिक रिएक्शन एंडोथर्मिक आसतना. एंडोथर्मिक मीन्स वेन हांव एनर्जी घेतलो आनी कितें करतलो? इलेक्ट्रॉन लूज करतलो. आर यू गेटिंग द थिंग्स हियर? आता सोडियम बी आसता, सोडियम तो कितें आसतलो म्हाका सांग? मोर हाय इलेक्ट्रॉन गेन एंथैल्पी और लेस इलेक्ट्रॉन गेन एंथैल्पी? सोडियम लेस आसतलें न्ही. सो इलेक्ट्रॉन घेवपाक ट्राय करपाना पळय, दिवपाक ट्राय करतलो. पूण तरी पूण जर फोर्सफुली आमी घातलो चड एनर्जी रिलीज करपाना तो 3s2 जातलो तो. सारकें न्ही? अंडरस्टँडिंग द थिंग्स हियर? आता फॅक्टर्स अफेक्टिंग इलेक्ट्रॉन गेन एंथैल्पी. Nuclear charge with increase, nuclear charge. First one is what? Nuclear charge. At just see here. With increase in nuclear charge, electron gain enthalpy becomes more negative. At the concept, see the concept. With increase in nuclear charge, electron gain enthalpy will be more and more negative. Can you understand? I am a nucleus. I am again nuclear charge. So, कोण इलेक्ट्रॉन येता का घट धरता, कोण इलेक्ट्रॉन येता का घट धरता. आता मागे न्यूक्लियर चार्ज चड म्हणल्यार इलेक्ट्रॉन सामको पूल करतलो म्हाजे कडेन. आर यू गेटिंग द थिंग्स हियर? म्हाजो जर न्यूक्लियर चार्ज चड इलेक्ट्रॉन पूल करून दवरतलो, मागीर एक सायडीन कान बंद जालो की जाता न्ही, कान बंद जाता रे. यू नो कान बंद जाल्यार तो आवाज येता पळय, पी तसलो आवाज येता. आतां कितें करपाचें? आनी गांवठी उपाय तुमगे जाता अशें केन्ना? मदीं बंद जाता आनी आवाज येता पी करून कसो. ओके, सो व्हॉट इज इलेक्ट्रिक? न्यूक्लियर चार्ज मोर म्हटल्यार कितें? वी विल होल्ड द इलेक्ट्रॉन्स व्हॉट व्हेरी टायटली. जो इलेक्ट्रॉन येता ताका घट धरतलो, इलेक्ट्रॉन येता कित्याक घट धरतलो? सो तेजी ऑटोमॅटीक इलेक्ट्रॉन गेन एंथैल्पी कितें आसतली? मागे न्यूक्लियर चार्ज चड आसा, सो मागे इलेक्ट्रॉन गेन एंथैल्पी कितें? More or less? More. So it will be more and more negative. Are you getting the things here? Nuclear charge में किती आहे? Force of attraction between the electron and the nucleus. So जितने nuclear charge चढ, तितने electron gain enthalpy will be more. So more and more negative. Just see the point now. If with increase in nuclear charge, electron gain enthalpy becomes more and more negative. Accept करता? Okay. With increase in nuclear charge, there is greater attraction for the incoming electron. Same thing. Clear असा? Clear असा? Lisa, are you understanding? Yes, sure. Kaita ne? Ashtari kaita. Ashtari. Second point. Size of the atom. Don't read the point. Don't read. Don't read the point. Size of the atom. असा अशा दोन atom असा. एकट्याची एकट्याचो शेल नंबर असा 2 आणि एकट्याचो शेल नंबर असा 4. Whose electron gain enthalpy will be more negative? A or B? 2 or 4? एकट्याचे साइज असा 2 शेल असा. एकट्याचे 2 शेल असतात आणि एकट्याचे 4 शेल असतात. आय एम आस्किंग यू whose electron gain enthalpy will be more? म्हणजे more negative. कोणाची असतली A काय B? A B. साइज चड असो काय साइज बारीक असपाक जाय. इलेक्ट्रॉन गेन एंथैल्पी मोर नेगेटिव्ह असपाक. See, if size is small, nuclear force of attraction will be more. So electron gain enthalpy will be automatic more. So electron घेतलो न्ही बारीक असल्यार. If it is big in size, will it take the electron easily? No, because nuclear charge will be what? Less. So now read the point. Size of the atom. As the size of the atom increases, the distance between the nucleus and incoming electron, what happens? Increases. And electron gain enthalpy will be becoming less negative. Accept karta. Understand Dada? Okay. Clear? Yes, Nikolai. Getting the things? Yes, Joseph? Okay, understanding? Are you understanding, Joseph? Okay, good. बरं. See. माझ्याकडे दोन ॲटम असतात. एक असा 2 शेल असतात, एक इथं 4 शेल असतात. कोणाची साईज ओढली? 4 असते गेलो. आता जर 4 जर एक इलेक्ट्रॉन येता, जो न्यूक्लियस ताका पूल करून दवरतलो. आता 2 शेलां येतो इलेक्ट्रॉन येता, ताका इलेक्ट्रॉन पूल करून न्यूक्लियस पूल करतलो. बट वेर इलेक्ट्रॉन विल बी पुल्ड मोर? 2 शेल और 4 शेल? 2 शेल शुअर. साईज बारीक म्हळ्यार बेगीन पूल करतलो न्ही. सो बेगीन पूल करप म्हळ्यार इलेक्ट्रॉन गेन एंथैल्पी मोर जातली. मोर नेगेटिव्ह. साईज व्हडली म्हळ्यार पूल करतलोच तो, बट विल बी दॅट मच इफेक्टिव्ह ना न्ही. सो इलेक्ट्रॉन गेन एंथैल्पी विल बी लेस नेगेटिव्ह. कळ्ळें? शुअर. नेक्स्ट पॉइंट. इलेक्ट्रॉनिक कॉन्फिगरेशन. आता मातशें ट्रिकी असते हो पॉइंट अंडरस्टँड जावपाक. इलेक्ट्रॉनिक कॉन्फिगरेशन इज ट्रिकी. सी the elements having stable electronic configuration or half filled or completely filled valence shell has less negative electron gain enthalpy. Can you tell me why? आता इथं why म्हणून रिझनच नाही. रिझन इज ऑलरेडी गिवन. आता माझ्या फुड्यान जर हाफ फील्ड आसा, हांव इलेक्ट्रॉन गेन करपाक ट्राय करतलो. कित्याक माझ्या फुड्यान कितें आसा? स्टेबल आसा. माझ्या फुड्यान फुल फील्ड इलेक्ट्रॉनिक कॉन्फिगरेशन आसा, हांव इलेक्ट्रॉन गेन करपाक ट्राय करतलो ना. कित्याक? स्टेबल आसा. आणि माझ्या फुड्यान जर हांव नोबल गॅस, हांव इलेक्ट्रॉन गेन करपाक ट्राय करतलो ना. सो हे तिनी कंडिशना भितर इलेक्ट्रॉन गेन एंथैल्पी विल बी मोर नेगेटिव्ह और लेस नेगेटिव्ह? Less negative. If my tendency to take, I am repeating again, if my tendency to take the electron is more, my electron gain enthalpy will be more and more negative. If my tendency to take the electron is less, my electron gain enthalpy will be less negative. Are you getting the things here? Understand that, Vedal? Okay, if I am taking an electron, if my tendency to take an electron, take now. If my tendency to gain of electron is more, म्हाका इलेक्ट्रॉन घेतल्यार म्हाका कितें तरी स्टेबिलिटी मेळटा, जाल्यार म्हाका इलेक्ट्रॉन गेन एंथैल्पी वाडटली, इन्क्रीज जातली. सो म्हाका व्हॅल्यू कितें आसतलो? मोर नेगेटिव्ह आसतलो. आता ऑलरेडी स्टेबल आसा, म्हाजे कडेन हाफ फील्ड आसा, आय हॅव फुल फील्ड और आय हॅव कंप्लीटली फील्ड. फुल फील्ड कंप्लीटली फील्ड स्टेबल कॉन्फिगरेशन. हांव इलेक्ट्रॉन घेवपाक ट्राय करतलो. सो म्हाका टेंडन्सी लेस जाली. सो म्हाका इलेक्ट्रॉन गेन एंथैल्पी विल बी लेस नेगेटिव्ह. नेगेटिव्ह व्हॅल्यू आसतलो, बट इट विल बी आयदर मोर, इट विल बी लेस. रिएक्शन खंयचे आसतले हांगा? एक्झोथर्मिक. आर यू गेटिंग द थिंग्स हियर? आता म्हाका सांग, across the period, now I'll go with the point. Sorry, down the group asa न्ही. Okay, down the group. What do you think? Down the group, electron gain enthalpy will be more negative or less negative? Think and tell me. Down the group, what happens to the atomic number of shells? Increases. So atomic size increases. So electron gain enthalpy more negative or less negative? Now read the point. Electron gain enthalpy becomes less negative. That is, tendency of accepting electron decreases due to increase in what? Atomic size. You remember, jana atomic radius and bomb martalo important. पण तेच कन्सेप्ट परत तेच आसा. रिजनिंग सगळे ऑलमोस्ट रिलेटेड आसात. आर यू गेटिंग द थिंग्स हियर? Don't confuse this with ionization enthalpy, please. Clear? Next point. Atora, across the period किती जावपाक जाय सांगूया? Across the period, more negative. But up to which group? A full group? Up to 70. 18 of law. 18 will be less negative. But मध्ये half field असा. असा नाही, half field असा नाही. Yes or no? Nitrogen is half field. Yes or no? So just see here. Electron gain enthalpy becomes more negative across the period. That is tendency of accepting electrons due to increase in what? Nuclear charge. But हे general दिला. हे general दिला सारखे नाही. कार्बनाची चढ असतली, कार्बन नायट्रोजनाची असतली more negative. But actually normally जर आम्ही जाय across the period, what happens to the nuclear charge? Increase. So nuclear charge increase आपल्या, you will pull the electron toward itself. So automatically electron gain enthalpy will be what? More negative. Like general, this is general. Okay? Can nitrogen is there, half field is there. So again, electron gain enthalpy तितली more aspana because it already has what? Half field. Half field configuration. Clear asa? So understood electron gain enthalpy? Yes? Clear asa? Okay? Good. The last most important concept I could say. हे बाकीचे पळय that is all theoretical. ते म्हाका लागा. The फाटली जे आसा पळय diagonal relationship बी ते मागीर पळय ते चड important ना मातशें ते. The most important and the last important concept is electronegativity. Last concept to understand. All of you understood ionization enthalpy? All of you understood electron gain enthalpy? Yes or no? And the last concept is electronegativity. Okay? And what is electronegativity? Yeah? It is a measure of the ability of an atom to attract shared pair of electrons towards itself in a covalent bond. Greater the electronegativity of an atom, greater is the tendency to attract the shared pair of electron towards itself. अरे देवा, समझ में आया? नहीं. ठीक. हे जे इलेक्ट्रोनेगेटिव्हिटी आसा पळय तेंची न्ही मातशी भानगडच डिफरंट सांगता. आता इलेक्ट्रॉन डोंट मिक्स दिस विथ इलेक्ट्रॉन गेन एंथैल्पी. इट लुक्स लाइक सिमिलर बट इट इज नॉट सेम. ओके. आता इलेक्ट्रोनेगेटिव्हिटी म्हळ्यार कितें सांगता स्टुडंट्स, एक जर कोण फर्स्ट थिंग द बॉन्ड शुड बी कोवेलेंट. यू रिमेंबर कोवेलेंट बॉन्ड I explained? Covalent radius I explained. Covalent radius, under atomic radius there is covalent radius, metallic radius, van der Waals radius. What is covalent radius? The bond formed by sharing of electrons. जो मेरा है वो मेरा है, जो तेरा है वो तेरा है. तेरा electron, मेरा electron will make a bond. That is a covalent bond. Sharing of electrons. आता electronegativity concept, what does it say? No. Also फ्लोरिनाचा पण स्टुडंट्स हायड्रोजन आणि फ्लोरीन. त्या फ्लोरिनाने एक वायट सवय. तो किती म्हणतो खबर आसा? 1s2 2s2 आणि 2p5 करेक्ट. सो तो सदांच रेडी आसा आपणा कोण तरी इलेक्ट्रॉन दिता काय म्हणून पळयता सारकें न्ही. दिता काय म्हणून पळयता हे सोडून. आणि बारीकसो जर कोण मेळ्ळो कोण आमगेलो हायड्रोजन बारीक न्ही बावडा तेका आनी कितें बट व्हेरी डेंजरस हा. सो व्हॉट ही इज डुईंग बिकॉज ऑफ इट high electronegativity. What is electronegativity? Tendency to pull the electron towards itself in the shared bond, and that bond is called as what? Covalent bond. Covalent bond is formed by sharing of electrons, and the atom which is pulling the electron towards itself in a covalent bond, that is called as electronegativity. आता म्हाका सांग, हायड्रोजन आणि फ्लोरीन कोणाक कोण दिसतो तुमका? तो इलेक्ट्रॉन ओढून घेतलो वो. जो मेरा है वो भी मेरा है, जो तेरा है वो भी मेरा है. Who will do this? Hydrogen or fluorine? And why? Because he will attain what? Stable electronic configuration of noble gas. So fluorine is the most and the highest electronegative element in our periodic table. Second highest is oxygen. Second highest is oxygen. The first highest electronegative element in our periodic table is what? Fluorine. पहिली फ्लोरिनाचा मागीर कोण आता? Oxygen. The best of the elements are there. Halogens are there. So, but the highest electronegative element is what? fluorine. So understood what is electronegativity? Ability to pull the electron towards itself in a covalent bond. Clear, Asa? Now I'll go with the point. Variation of electronegativity in a period. So म्हाका सांग across the period तुमको किती दिसता कोण इलेक्ट्रॉन आपणाकडे पुल करपाक ट्राय करतलो इन अ कोवेलंट बॉन्ड सोडियम or fluorine? Sodium. So electronegativity across the period किती जावपाक जाय I or D? Electronegativity should increase or electronegativity should decrease? सोडियम ट्राय करतलो आपणाकडे इलेक्ट्रॉन घेवपाक काय सोडियम ट्राय करतलो इलेक्ट्रॉन दिवपाक इन अ कोवेलंट बॉन्ड दिवपाक ट्राय करतलो what fluorine will do he will try to pull आता सांगला न्ही fluorine is the highest electronegative element so across the period electronegativity should increase or should decrease I or D I so now read a point it increases across the period from left to right lithium to what fluorine याद ना only up to fluorine due to increase in what atomic due to decrease in atomic size and increase in what nuclear charge clear asa in general this is general there are some variations in between that I will not do in general याद धरपाचें as a result of increase in nuclear charge the attraction for the outer electron by the nucleus increases in a period and down the group किती जातले म्हाका किती जालें okay see across the period what happens to the nuclear charge increases का I काय D increase जाता increases across the period nuclear charge increases आज जर हांवें एक कोवेलंट बॉन्ड केला कोणा वांगडा आनी म्हागेचो nuclear charge चड आसा I will pull my electron but म्हागे nuclear charge चड आसा I will pull the other electron also no in a covalent bond म्हाका जर एक इलेक्ट्रॉन जाय then I can pull no म्हाका स्टेबल करपाक so lithium will do that or sodium will do that no but fluorine will do that no कित्याक एक इलेक्ट्रॉन जाय so in a covalent bond तो आपला इलेक्ट्रॉन करपाक जेन्ना bond break जातलो when this is happening not just when bond is able to break then तो कितें म्हणटलो hey तेरा इलेक्ट्रॉन दी मेरा go are you understanding the things here why he will do because he has that nuclear charge so across the period what happens to the nuclear charge increases so ability to pull the electron towards itself is more and in a that thing we are applying in a covalent bond this is for every element in a covalent also it will remain same it will not change so that's up to fluorine not neon neon electron जाय तुम्ही इलेक्ट्रॉन दियात ना इलेक्ट्रॉन घेयात त्याका कांयच मॅटर करना आपण स्टेबल आसा तुम्ही आपणा भानगडी पळा तुमची पडटा नॉर्मल गॅस कॉन्फिगरेशन न्ही एवरी एलिमेंट पळय तो कितें म्हणटा व्हॉट ग्रुप 18 सेज तुमकां जाय जाल्यार तुमी आमी आमचे भशेन जावपाचें वी आर द बेस्ट आमी तुमची भानगडी ना दॅट्स व्हाय वी आर ग्रुप 18 तुमकां जाय जाल्यार एक इलेक्ट्रॉन घे आपणा फुडें यो नाल्यार एक इलेक्ट्रॉन लूज कर आपणा फुडें यो आर यू गेटिंग द थिंग्स हियर तुमकां जाय जाल्यार तुमी स्टेबल नॉर्मल गॅस करात आय एम स्टेबल क्लियर आसा अंडरस्टँडिंग द थिंग्स हियर आता डाउन द ग्रुप किती जातले सांग डाउन द ग्रुप आय एम नॉट रिडिंग द पॉइंट डाउन द ग्रुप किती जावपाक जाय डाउन द ग्रुप किती जाता नंबर ऑफ शेअर्स किती जातात increase जाता atomic radius atomic size किती जाता increase जाता so electronegativity किती जावपाक जाय I काय D I or D वेदाल size increase जाता so electron pull बेगीन करतलो जातले electron pull करपा आसल्यार size व्हडली आसल्यार ना न्ही so down the group आमगे size increase जाता न्ही because number of shares किती जाता आमगेले increase जाता कळना lithium sodium potassium rubidium cesium this is down the group lithium has how many electrons 1s2 2s1 sodium is 1s2 2s2 2p6 3s1 1s2 2s2 2p6 3s2 3p6 4s1 so anga second shell anga third shell anga fourth shell so down the group shell increase जातात so shell increase झाली size increase झाली yes or no so potassium can pull the electron easily lithium can pull the electron easily lithium is size बारीक आसा न्ही here nuclear charge is more here nuclear charge is what less so down the group electronegativity should what I or D decrease understanding now read the point variation of electronegativity in a group electronegativity decreases from top to bottom as the distance of the outer electron from the nucleus increases meaning कि then nuclear charge decreases atomic radius increases. कळ्ळें वेदांत? अंडरस्टँड जाला मातशें तरी? हें कळ्ळें तुका आतां? डावन द ग्रुप इलेक्ट्रोनेगेटिविटी म्हळ्यार कळ्ळें? Should I explain again electronegativity? होय जाल्यार होय म्हणून ना जाल्यार सांगता इलेक्ट्रोनेगेटिविटी म्हटल्यार एक कोवेलंट बॉन्ड करता. इन अ कोवेलंट बॉन्ड एबिलिटी ऑफ एन एटम टू पुल दॅट इलेक्ट्रॉन टुवर्ड्स इटसेल्फ. आपलोय बी पूल करतलो आनी दुसऱ्याला बी आसा पळय तोय पूल करतलो. आता जर तो पूल करपाक जाय एक म्हळ्यार तेशें न्यूक्लियर चार्ज सारको आसपाक जाय, चड आसपाक जाय. आर यू एक्सेप्टिंग दिस? न्यूक्लियर चार्ज शुड बी मोर. Along with that, along with the nuclear charge, it should have a small size. Yes or no? आता down the group आमगे nuclear charge increase जाता काय decrease जाता? Okay, down the group size किती जाता आमची? Increase जाता. So size increase means nuclear charge will decrease. Force of attraction from the electrons to the nucleus will decrease. And if the nuclear charge decrease जाता, electronegativity will also what? Decrease जाता. Understand जाता आता? Across the period की जाता, atomic radius की जाता, decrease जाता, nuclear charge की जाता, increase जाता. And if nuclear charge is increasing, electronegativity also will increase. But up to what? Fluorine. Neona जावपा ना के neona किती आसा? Fully filled stable configuration. Clear आसा आता? There are some exceptions in between. This is a general exceptions are there. P block खूप exceptions असतात. Because there are half-filled configuration, there is variation in atomic size. Okay, सांगलेलं आहे screening effect, d orbital electrons, they show poor screening. कोणा तरी मेळपाक गेल्ले आमी पेपर जावन कोण ते? हा मेसी कोण मेळपाक गेलो तो? हातू गेल्लो. मागीर मदीं कोण MLA आयले ताका सोडून तुका आपयले तेणे. Because they show what? Poor shielding. Okay, so that's the effect are the things. So तितले आमकां डिटेल वचपा नाका सद्या. Understood? Atomic radius, ionic radii, isoelectronic, ionization enthalpy, electron gain enthalpy, and electronegativity. Clear आसा? आणि एक बारीकसो टॉपिक उरला, but I would say with this I have finished with the chapter. Okay, आता एक बारीकसो तो concept आसता पळोवया. This concept, okay, कितें तरी बरयता मातशें वाचून पळयात आं. I will not go with that electronegativity, metallic and non-metallic character. For me, this is important. Number of valence electrons. Okay, and diagonal relationship. Relationship म्हटल्यार तुमचे दोळे पहिले ओपन जातले. And diagonal म्हटल्यार कशें पळोवपा आणटो? मेरे नीचे वाली खिड़की में एक चांद का टुकड़ा रहे. You heard this song? मेरे सामने वाली खिड़की में एक चांद का टुकड़ा रहता है. No one heard? Never? मेरे सामने वाली खिड़की में. Oh, this is from 80s or 70s something song, but still it is famous still now. Okay, so many people sing this song also. But song. Yeah. So like this also here, मेरे नीचे वाली खिड़की में एक चांद का टुकड़ा रहता है. So lithium would say to whom? Magnesium. Beryllium will say to whom? Aluminium. And boron will say to whom? Silicon. मेरे नीचे वाले, मेरे अगले वाले बिल्डिंग में नीचे वाली खिड़की में. I will show you here. लिथियम, सोडियम, पोटॅशियम आणि रुबिडियम. हांगा कोण येता? बेरिलियम, मैग्नीशियम. सो वो कोणाचे लाइन मारता? मैग्नीशियम. मेरे सामने वाली बिल्डिंग में नीचे वाली खिड़की में हु इज देयर? मैग्नीशियम. आता व्हाट इज दिस डायगोनल रिलेशनशिप? What is this diagonal relationship? Diagonal relationship means they have the same properties. They have what? Same properties. So let's read this. Okay, first I will go with this valence part. Periodicity of valence or oxidation state. So just try to understand what are valence electrons. The electrons present in the outermost, ते सेल बरेचे शेल करपे मातशे बायोलॉजी आयलो मदींच. सेल बरयला. जाता रे टायपिंग एरर. This is the size of these words. 12 दवरलेले हांवें. Okay, the electrons are present in the outermost shell are called as what? Valence electrons. कळटा? म्हाका सांग सोडियमाचे valence electrons कितले? 1. कळटा? Good. Valence electrons, and this electron determines the valency of an what? Atom. In case of representative elements, wait, carbon can make how many bonds? 4. Because कार्बनाच्या outermost shell electrons कितले असतात? 2p. कितले? 4. ताका लागून तो 4 bonds करता. because the valency is what? 4. But this is not applicable to each and every element. See here. Group 1. What is the valency of group 1? 1. Group 2. 2. Group 13. 3. Group 14. 4. Group 15. 3 and 5. No valency. I know हे valency शिकताना आम्ही सगळे फुटपास I know this. See, wait. असा नाही अजून हांव काय केलो गॅस जाल्यार तो भूत जावन येतलो. This is for sure. Okay, group 1, group 2. आता हेजे मदीं सांगल्या पळय कोण सांगले आमी 3 to 12. They are very dangerous. D block elements, very dangerous. मागीर कोण आयलो 13, 14, 15, 16, 17 आणि 13. Very easy to understand. See, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine आणि neon. आता तरी मागचं periodic table याद जाता मास्टर तरी याद जाता. This is which period? This is in which period? Second नी कशें कळटा 1s2 आणि 2s1. 1s2 आणि 2s2 outermost shell. Second period. First period आमगे एकटोच आसतलो भाऊ helium एकटोच आसतलो 1s2 नी 1s2. So अशें करून याद धरपाक पळया. What is the valency? How many electrons in the outermost shell? 1. So valency is what? 1. How many electrons in the outermost shell? 2. So valency is what? 2. 1s2, 2s2 and 2p1. How many electrons in the outermost shell? Outermost shell 3. कळटा न्ही 2s2 plus आणि 2p. Shell, not subshell. Shell. So second shell 2 plus 1 3. So just check for 14 4. आता 15 पळय 15 पळय valency आणि valence electrons is different. Yeah, here it will be 2s2 2p2 2s2 2p3 2s2 2p4 2s2 2p5 and 2s2 कितें 2p6. So हेची valence electrons कितले 4. हेची valence electrons कितले 3. हेची कितले 5. हेची कितले 6. हेची कितले 7 and हेची कितले 8. Just check the valency is correct. Valence electrons कळ्ळें. आता valency students depend उरता how many bonds it can be. Valency depends on how many bonds it can be. So for like example 15 कोण आमगेलो सांग नायट्रोजन पळय नायट्रोजन नी चडशी नायट्रोजनाची valency is 3. नायट्रोजन केन्ना पयले नायट्रोजन फॉर्म्युला इज लायक दिस. नायट्रोजन केन्नाय पळय अशें 3 बॉन्ड्स करतलो करेक्ट आसा असो आनी आमकां दोन तिकलीश्यो आसतल्यो लोन पेयर्स म्हणटा ताका ते आतां नाका टेन्शन घेनाका. केमिकल बॉन्डिंग एंड मॉलिक्युलर स्ट्रक्चर चॅप्टर नंबर 4 आफ्टर एग्जाम आय विल स्टार्ट तेन्ना क्लियर कळटलें. But nitrogen has how many valence electrons? 5 valence electrons. Out of which he uses only how many to make a bond? 3. So त्याची valency 3 आणि किती आसा पळय 5 आसा. 5 केन्ना यूज जायना मोस्टली किती यूज जाता 3. केन्ना 4 सुद्धा यूज जाता. बट 4 यूज करप म्हळ्यार तेचे पॉझिटिव्ह चार्ज येता. सो आय विल नॉट गो इन दॅट मच डिटेल. इतलें याद धर हांगा valency कितें आयदर 3 और कितें 5 आनी मोस्टली कितें आसता 3 आसता. अंडरस्टँड जाला. आता ऑक्सिजनाची valency पळय 2 आणि कितें 6. आता पळय ऑक्सिजन केन्ना पयलो असो आसतलो. हॅव यू सीन लायक दिस एनी टायम असो आसतलो फुल्ली पयल्यार. हॅव यू सीन दिस. सो ऑक्सिजन किती बॉन्ड ट्राय करता तूं 2 बॉन्ड करता डबल बॉन्ड करपाक ट्राय करता. वॉटराक सुद्दां असो आसता पळय वॉटर 2 बॉन्ड आनी अशें आसतलें. हॅव यू सीन दिस एनी टायम. सो हे इलेक्ट्रॉन्स यूज करना तो बट इट हॅज valence electrons how many 1 2 3 4 5 and what 6. But what is actual valency of it is the electrons which is used to make a what bond. Right? Understand आता. आता कार्बन आपला 4 इलेक्ट्रॉन यूज करता. कार्बन what is the valence electrons of carbon 4. He make all the 4 bonds. That's why carbon is important. The C in chemistry is carbon. म्हणून कार्बन थर्ड कंपाउंड्स करता. Have you seen no many compounds carbon compounds are there. Hydrogen, yeah, mostly with hydrogen. Second hydrogen बऱ्याक जमता. Huh? CH2 CH3. Understanding the things here. Okay, so I will not go in detail of this much more. आता okay, oxidation state. ऑक्सिडेशन स्टेट म्हटल्यार have you seen any like this Na plus पहिला केन्ना Ca2 plus this is called a charge on the atom is the oxidation state the charge on the atom आता what do you think chlorine will try to become chlorine plus 7 or Cl minus so common oxidation state किती असतो त्याचं -1 sodium will try to become plus 2 or plus 1 plus the common oxidation state किती असतो plus 1 are you understanding the things this is called as oxidation state okay I just will read the point so variation down the group not required okay down the group number of valence electron remain the same therefore all exhibit same oxidation state of group 1 as +1 and group 2 as +2 मग सांग ग्रुप 1 चे एलिमेंट्स आसा पळय आमगेले लिथियम सोडियम पोटॅशियम रुबिडियम आणि सिजियम what they will try to do what will be their charge +1 आसतलो न्ही एकच इलेक्ट्रॉन लूज करतलो सोडियम किती आसतलो प्लस के किती आसतलो प्लस रुबिडियम किती आसतलो प्लस so like that what will be for group 2 beryllium magnesium calcium strontium आणि barium what will be this charge so have you seen magnesium most of the time 2 plus because ते दोन इलेक्ट्रॉन करून ते किती मेळटा stable noble gas configuration are you understanding the things here so that detail I'm not going in detail roughly सांगता roughly so like that our halogens group 17 the elements you might have seen like this Cl minus F minus Br minus I minus सारखे न्ही have you seen any time they are plus there is plus Cl plus in all is there but most time it will be what minus कित्याक म्हणजे ऑक्सिडेशन कॉमन ऑक्सिडेशन स्टेट किती असतली -1 किती असतली सांग बिकॉज दे विल अटेन व्हॉट स्टेबल नोबल गॅस कॉन्फिगरेशन अंडरस्टँडिंग कळटा सो दॅट इज ऑक्सिडेशन स्टेट ओके आता लास्ट प्रॉपर्टी दॅट इज डायगोनल रिलेशनशिप सो डायगोनल रिलेशनशिप म्हटल्यार कितें why they show anomalous behavior okay then अनेक पॉइंट उरला anomalous properties of second period elements which are the second period elements lithium beryllium boron carbon nitrogen oxygen fluorine and what neon they show anomalous behavior anomalous म्हणजे किती मातशे different behave करता then the first element they मातशे different behave करता then the first element elements in a group show similar physical and chemical properties however first element of each group that is lithium then what beryllium then what boron carbon nitrogen oxygen fluorine they show what not neon up to fluorine जे every ग्रुपाचो first element किती show करतलो असं different behave करतलो and the reason for this is that mark the reason why they show anomalous behavior why the first element of each group show anomalous behavior the first reason small size of what atom second reason किती are you accepting every first element of group period 2 will have high electronegativity if I go down the group yes not like this every first element of period 2 every first element of each group will have high electronegativity are you accepting this yes or no then down the group electronegativity ki jata decrease jata so every first element of each group will have high electronegativity you also accept this every first element of each group will have small size every small element of each group every first element of each group will have small size yes and third reason for it non-availability of d orbital every first element of each group whether they contain d elements they contain d orbitals no so these are the three reasons why they show what anomalous behavior what is the three reasons because of the small size second one high electronegativity and absence of what d orbitals inavailability means absence of d orbitals understood and the last one diagonal relationship why they show diagonal relationship every second period show similarities with the elements of the third period placed diagonally to its right this is called as what diagonal relationship because मेरे सामने वाली ग्रुप में नीचे वाली खिड़की में, मेरे सामने वाले ग्रुप में, नीचे वाली खिड़की में, which is diagonal to him, that because why they are diagonal relationship? Because they have what? Same physical and chemical properties. Understood? आता बाकीचे जे आसा पळय, you just go through this. With this, I have finished with the third chapter. Clear asa? Okay, let's revise. Take 5 minutes to break it up and we'll start. So I can do the revision for the remaining 2 classes. So Rosales, I will do the revision for you all of the first chapter. Not now, huh? Energy not quickly. First chapter. I think there are many concepts in first chapter. Don't tell me to revise. Structure of atom, huh? Okay, so what I will do, I will just name the concepts of the first chapter and you tell me which to revise in the next class. Okay, first concept is that mixture. जाय म्हाका जाय गरज ना. मागीर आसात significant figures. Is it required? No? Ora. No? But how much you know? 2, 3, 4, 0, 0. How many significant figures here? What is the definition of significant figures? Own words सांग. Meaning कितें? कोंकणीन सांग. I also do the same thing. English in सांगता definition, कोंकणीन explain करता. So you should also do the same thing. Significant figure म्हटल्यार it gives a specific information, specific digit, specific value. आता हेचे significant figures कितले? He's telling the number. आता हे इतलेच जर significant figure म्हळ्यार हेचो value काय ना तो जालो न्ही. Is it correct? No. Imagine 2,34,000 is given. If I am saying only 3 significant figures, I will give only 234. Don't zero on now. So, call to meaning call. Okay. How many significant figures now? 1, 2, 3, 5. 5. 5. He's still saying 5. 7 or 5? He's still saying that. What about these 2 zeros? Okay, wait. Rule देखो बरा था उनका problem तो after decimal if 0 is there we consider as a significant figures. आता पण या दोघांचे भितर meaning कितले change जाता पहिला एका आम्ही 3 म्हणता एका आम्ही म्हणता 7 not worth as such no. Okay, but actually significant this is actually there are some doubts still it's not finalized but आम्ही 3च म्हणपाचे एका. Okay, आणि Avogadro constant value कितना है? 10 to the power 23. Okay, sorry. आता सांग. म्हणत ना? Sure. चेक कर रहा है? Correct. Positive, correct. Tell me how many significant figures here? Everyone is saying 4? I said it's Avogadro's value. Yes or no? I said it's a constant value. And what's a significant figure for a constant value? Infinite. Yes or no? You all are correct. It is 4. But if I am saying this is my constant value, then tell me. Then it is what? Infinite. नहीं? Are you getting the things here? For a constant value, the value constant would follow, the value is infinite. The significant rule is saying like that. I don't know if you know these things are. I can. For a constant value, the significant figure is what? Infinite. Now, don't get confused with that. If a teacher tells you that it's a constant value in a question, then you will write what? Infinite. Now, then you all are correct. Understand? Ek rules important. Huh? Then sometimes the teachers will give 10 apples. What's the significant figure here? Are Deva. Then you don't know this rule. 1. How many? What's the significant figure here? 10 apples. But physics का study करा, chemistry का study करा. Infinite. How infinite means 10 apples? Will it change? See, I don't know. तुम्ही खुशान किती शिकल्या त्या? Rules दिल्या significant figures. On the notebook you have written. Open कर. Huh? In the notes. फिजिक्साचे केमिस्ट्री दिले म्हाका केमिस्ट्री फर्स्ट चॅप्टर नोट्स किती करता रे तू रिटर्न rules are written check the last rule then write the last rule what is the meaning of that read the last rule it is given in the notebook first chapter example देऊ ना टीचर त्याला पण see read the last rule no we joined late दिला नहीं so what is the rule read see if it is 10 apples 8 apples or a fixed digit is there fixed value is there for something then that significant figure is infinite please keep it in mind it is given that value is infinite understood quite not given so this is example for finite I'm telling you the rule okay forget about that how confused okay I was just telling you the significant figures okay so you will do significant figures pura maga but in the exam it is given 10 apples 10 balls whatever is given if such things are given then write infinite okay this rule is there on the textbook also any reference book after that loss should I explain now explain करची पडटले see loss explain करपा ना understand the loss the examples are given for loss on the textbook examining teacher example ditli they will ask you which law it is and they will tell you the write the law be careful with this Loyola Damodar's rosaries this type of questions are asked they will give the example situation ditli tumka solution A solution B this is mixed in this then they will ask you which law it is and then they will tell you to write the law understood then the next concept comes is dimensional analysis like addition of significant figures you have to round it off less than 5 more than 5 physics same thing is applicable in chemistry that's why chemistry is not done it is not done mostly in chemistry because it is done in physics now direct I actually do I cannot finish this listen I always finish the third chapter on the last day my exam I stop आता किती बेगीन झालं because this is I explained that everything dimensional addition subtraction less than 5 more than you know these things no enough same thing we apply in chemistry college केला आहे dimensional analysis in chemistry it is done दामोदर सा असतले तुमकां असत all three दामोदर दामोदर सगळे असता दामोदर हा गोशाणे दामोदर हा ओके त्याका लागून म्हाका करची पडटा न्ही आय कॅनॉट कीप एनी कन्सेप्ट दामोदर भुरगीं रोखडी उठता सर आमकां केला I tell you the thing. After that dimensional analysis, Satare, the most important mole concept. जेन्नाच्यान तुमकां first chapter difficult start जाता. Mole concept. In mole concept, the first thing is a mole concept. Calculation of molecular mass. एक question येता. Molecular mass, atomic mass will be given. You have to calculate molecular mass. मागीर question येता तुमकां stoichiometry. कितली ग्रॅम दिल्ले आसतले कितली ग्रॅम किती जाले कंबशन जालें हे जालें दोन क्वेश्चन आफ्टर कम्स द मोस्ट द हार्ट ऑफ द चॅप्टर concentrations mass percentage volume percentage mass by volume percentage molality mole fraction सारखे न्ही ओके and अनेक concept आसा limiting reagent and limiting reactant in how many schools it is done only in Damodar limiting reagent, limiting reactor, no. Molecular formula, empirical formula, done, no? Okay, so out of this, tell me what I have to do your revision. Next class, from the first chapter. Molecular formula, empirical formula. Mass percentage, volume percentage, what I will do now? I will explain you first. Then I will give only one numerical which will cover all the concepts. एकच example घेतलं हा numerical, it will take 2 pages to solve. So सगळे concept यातले दिसतील. Okay, number of moles. How many formulas are there? Which are those? Given mass upon molar mass, volume at HTP upon Avogadro's constant, and volume upon Avogadro constant, volume upon 22.4 liter, and number of molecules upon given Avogadro's. I repeat again. Number of moles is given mass upon molar mass, volume at HTP upon what? 22.4 liter, and number of molecules upon given Avogadro's constant. Don't like number of given molecules. Sometimes given molecules are asked. Number of moles is given. Clear, sir? Okay. From the second chapter, what I will do now? First chapter, can I start now only? बऱ्या पडटा तुमकां झालो टायम न्ही टायम झालो न्ही पाशेच ना न्ही मातशें सुद्दां ना न्ही ओके I will stop for today. Thank you everyone. See you in the next vlog. झालो न्ही टायम आनी कितें आसो लास्ट क्लास न्ही जाय पडटलो तो न्ही एक कितें काम कर रजनी मिस मेसेज कर मुगो रजनी मिस यू नो स्नेहा मिस just message her and tell her the date Sunday's date and tell her to send a chemistry video. She will send. तरी पूण जर पुन्हा व्हिडिओ पण कळपा ना बेजार येतलो आतां सांगता हांव सांगता आय नो दिस थिंग कळना जाल्यार म्हाका विचार तूं कॉन्सेप्ट कळना तो ओके गो थ्रू द नोट्स आनी विचार म्हाका आय विल एक्सप्लेन तुमी एग्जाम केन्ना स्टार्ट सो आमकां टायम आसा